In this video, we're going to talk about a topic called conjugate acids and bases. And really, this typically ends up being a lot more complicated than it needs to be. But frankly, all we do is if we have a weak acid, if we have a weak acid or a weak base, let's get a pen back here. There we go. A weak acid or a weak base. And since they're weak, we have a reversible reaction here. When they react with water, they're going to form the conjugate of what they were. So a weak acid will form a conjugate base, a weak base will form a conjugate acid. Let's look at an example of a weak base. How about, let's see, how about a phosphoric acid? Remember, this is reacting with water. So water is going to pick up one of its protons and form a hydronium ion. All right, well, let's see. The weak acid, let's talk about the weak acid here. Weak acid. And what is its conjugate base? Well, it got rid of the H plus, so the conjugate base is going to be the H2PO4 minus 1. Because in the reverse reaction, this will pick up the H plus from hydronium and form the weak acid. All right, then the conjugate base of a weak acid is a weak base. This acts as a weak base just like this acted as a weak acid. Now, how about a weak base? How about ammonia? That's a weak one. Let me get my green. All right, it's going to react with water. All right, NH4 plus OH minus. All right, so going back to red, well, actually, since it's a base, let's try blue. Our weak base is ammonia. Well, where's its conjugate acid? We got to find, remember, acids have an H plus to give away. Oh, there it is. All right, so really, they're nothing more, conjugate acid is nothing more than the product of the weak base once it reacts with water. And remember, it has to be acidic, it has to have the proton to give off. And a conjugate base is going to be usually the anion of the weak acid after it deprotonates. So if you see something negative in solution there, and it was it gave off a proton, it's a dead giveaway. You have a weak acid and you have its conjugate base. Look for that negative sign, and that's going to be a dead giveaway. So hopefully this will help you on your problems regarding conjugate acids and bases. The one thing I want to really stress and emphasize here is that, let's try yellow, strong acids and bases strong acids and bases will form conjugate acids and bases, but they're not going to have any true strength. Okay, so you could pick apart hydrochloric acid dissociating water, forming the hydronium ion and a chlorine anion, and that chlorine anion will be a conjugate base of the very strong acid, but it really doesn't have any basicity whatsoever. So really, this concept, even though literally you can say this is the conjugate of this and this is the conjugate of that for strong acids and bases, really they have no bearing on solution pH on anything really. So strong acids and bases, even though you can kind of pick a conjugate base and a conjugate acid, their conjugates don't have any strength whatsoever since they're fully protonated and we don't have reversible reactions. Okay.